I will use an example to explain the operation of the Floyd algorithm and explain some logic. In order to have easy proof, I will use an undirect graph to explain this question. So consider we have 4 points. It is white, green, red, and blue. And we also have a matrix. In the Floyd algorithm, let us choose a fixed point first and then test all the other pair of points. The distance between I and K, the distance between K and J, and the distance between I to J. If the original distance is greater than the new distance, we will change it to new distance and change the value in the E matrix. Um, so in this question, the first step, we chose white as the fixed point, and we will check all the other pairs, like from 2 to 3, which means from green to red. If it passed white, the value is 1 plus 4 is 5, but it's greater than 1, so it not change. And from 2 to 4, it's 1 plus 7 is 8 is greater than 5 too, so it's not change too, and so on. In the first step, nothing will change. And second, in the second step, we will choose the green point as a fixed point. In this step, we find that from 1 to 3, it means from white to red, the distance is 1 plus 1 if it's past green. It means it's white, green, red. Distance 1 plus 1 is 2. It's shorter than from white to red. So it changed from 4 to 2. And so this from 1 to 4 is the white to blue. It's also changed from 7 to 6. And so we in the E matrix, we change the position that 1 to 3, 1 to 4, 3 to 1, 3 to 4 from 0 to 2. And in the third step, we chose white point at fixed point with the same like before. We found we changed the distance from 1 to 4, 4 to 1, 4 to 2, 1 to 4, 2 to 4. So we changed the egg matrix that the position 2 4 2 2 1 4 2 4 from 2 or 0 to 3. And in the final step, we chose the latest point B, blue. It's also fourth point at fixed point, and we also find there's nothing to change. So this is the final step, and we got the final matrix, and this is the final E matrix. For example, if we want to find the shortest path from white to blue, it means from 1 to 4. We found the value in the A matrix is 4, so it means the shortest distance. Sorry. It's the final step. I will do it again. Sorry. We chose blue as the fixed point, and it means the fourth row value and fourth column value will not change. And we will check that from 1 to 2, the new path distance is 4 plus 3 is 7. 7. But it's greater than the before. It's 1. So it's not changed. And from 1 to 3 is 4 plus 1 is 5 is also greater than before 2, so it's not changed. finally we check this from 2 to 3. If 3 plus 1 is 4, it's also greater than 1, so it's not changed. So it's the final matrix, and also we got final E matrix. For example, if we want to find the shortest path from white to blue, it means shortest path from 1 to 4. From 1 to 4. I found value in the matrix is 4. 1, 4. So it means the shortest sorry, distance is 4. And we want to find this path. So we look the E matrix. 1 4 value is 3. And 3 means the right point. What it means? It means that the shortest path from white to blue must pass right. So we got the path white, right, and blue. And then we will find that what the short path from white to right is from 1 to 3. 1 to 3. We also look the E matrix. 1 3 is 2. 2 is the green point. So we know that this position is green. And we know this no point. We can check it too. It's from right to blue. It's 3 to 4. 3 4 is 0. So there's nothing. So we got the final result that the shortest path from white to blue is the white to green to white to blue, and distance equals to 4. We can use the same method to find all the shortest paths from one point to another point. There's two logic I want to explain. The first is the why when the k plus 1 loop finish, that the situation becomes from the shortest path only pass through top k points to top k plus 1 point. What it means that, for example, if after the first loop we found that the shortest path from 3 to 4 is 3 1 4. It's the shortest path. And in the second loop, we will consider the second point as the fixed point, and we will compare the distance from 3 to plus distance from 2 4 and compare it with 3 4. The logic I want to explain that did we consider all the possibility? All the possibility in this loop, we should consider all the past value that 3 4 3 1 4 3 2 4 3 1 2 4 and 3 2 1 4. Then while we finish the second loop, that we compare all the 5 distance I total. And why? Is that true? Is that we really consider all the possibility? I think the answer is true because during the second loop, when we calculate the distance between 3 2, because we finished the first loop, actually when we calculate this, we actually calculate the 3 2 and 3 1 2. And same when we calculate the distance from 2 4, we actually calculate the distance from 2 4 to 1 because we calculate this 2 in the first step. And also, when we compare it with the distance 3 4, we actually calculate the distance 3 4 and distance from 3 to 1 to 4. So if we plus these two together and compare it with this, we actually do these 5 compared together at work. So it's the true. And the second logic I want to explain is very simple. It's right. Why we stop the loop immediately when we get a negative circle? What means negative circle? Consider we have 4 points again. In the A matrix, we think the mm, value in matrix that 1 point to itself is old 0 because we don't need to move. But if we got a matrix that, because in the example before, old value is positive, so when we plus them together, we can't get a value that's less than 0. But if we have some negative value, so like -1, minus -2, we may get some situation that the value from 1 point to itself it becomes to a negative value. For example, what it means that if from 3 to 1 is to 1 to 4 is -2 and 4 to 3 is -3, that we got a negative circle that from 3 to itself we got a total -3 pass. And at this moment we will stop the loop. And why we stop it? Because if we keep doing that, we will get a path which value is becomes negative infinity. What this means, if it means that if we want to find shortest path from, for example, from 2 to 4, we can make 2 to 3 first, and no matter what number in this, it doesn't matter. And we will do this circle infinite times, and then we stop at 4. And so we got a negative infinity path. So this is wrong. Thank you.